It's been about a week since I last JavaScripted. And I know you guys are all here because, you know, you have a lot of emotions and feelings towards JavaScript. And I think like most worthwhile relationships, it's a very complex mixture of love and hate. And I appreciate that. JavaScript reminds me of my wife a little bit. Anyway, so my talk is going to be looking, I guess, at a passive-aggressive tale of JavaScript. And I certainly am of the opinion that JavaScript is changing rapidly. And I'm not too sure. You guys are obviously aware of just how crazy JavaScript has been getting over the last couple of years. Anyone here done any work on Node? A few hands? So that's fucking crazy, because you guys are writing server-side scripting in JavaScript, which is blowing my mind. And it's one of those things where we often have to stop and kind of think where, you know, you look at something like Chrome. And Chrome has 4 buttons and like the little burger menu thing, or the 3 dots or whatever it is. And it looks really, really simple. And everyone has it, and you don't need a license to use it. And my mum uses this, you know, and she seems to not get completely owned all the time. But Chrome is really, really fucking complicated. And like what it's doing with JavaScript is also really, really complicated. And then you think about how it's made its way into everyone's pocket. And I want everyone to pull out their phone right now and open up Chrome. And up the top, it'll tell you how many tabs you have open. And I want you guys to shout out like some numbers for how many tabs you have open in your mobile browser. 1, 4, 6, we've got 10, 20, go on once, go on twice, 28. It's fucking crazy, right? And people, you don't, I mean, browser context in mobile Chrome is obviously great because it puts JavaScript to sleep when it's in the background, which is obviously fantastic. But then if you think about your laptop or your work laptop, you probably have 2 or 3 Chrome windows, and if you're like one of my directors, you'll have like 40 tabs. And they're all doing something. Like he opens his computer and shit is happening, and there's no way he knows what is happening inside of his computer. And like JavaScript and browsers to me are super interesting. I was fortunate to be invited to co-author a book on some miscellaneous JavaScript shit, and the primary author, Wade, has this really great anecdote. Like, let's imagine that you could pull an information risk professional from the 90s, or even like the 80s into nowadays, and you tried to make him do a risk assessment of a web browser and said, you know, hey, we've got this piece of software and we need to install it on everyone's computer, and it accesses the internet where we don't know what it's going to access, and at the same time, it's accessing the sensitive resources in our intranet, and it's doing things in the background, and we've got a mixture of kind of code and control language in the same space. You know, what do you think is going to go wrong here? And this poor, you know, 80s businessman with his big shoulder pads, his head would probably explode. Ignoring the fact that we just time traveled an 80s businessman into 2017. Whatever. And look, it's not all bad. You're thinking to yourself, okay, JavaScript, who really gives a shit, okay? It's not like you can get JavaScript and bad JavaScript will immediately result in arbitrary arbitrary RCEs on computers or bad binaries. But then you have to remember that like JavaScript is generally the platform for most drive-by malware these days. And this shit is obviously causing people a problem because they're still getting impacted by it even today. And then you have some other really interesting services such as your everything IoT, and you run your light globes and you run your cameras, and these things run your home network, and you kind of like, you're not too concerned about them, but then they've got a CSRF vulnerability that can obviously make them do bad things. And CSRF is like one of my favorite vulnerabilities. I know PayPal and everyone has this problem. I just pulled out a couple of websites. And I think this concept of what JavaScript is doing now, like if we look at what it's doing right now, it's already pretty freaking crazy. And if we project forward into a way that we're shifting from this general purpose computing platform to kind of more dedicated computing, like iOS and Chrome OS and rest in peace Firefox OS, like we're kind of shifting from being able to run arbitrary executables on our computers, but then that's left a gap. And people want to do shit with their computers, And so JavaScript is empowering them to do that with all sorts of craziness. And this is just like a short list of random stuff that we are now seeing in browsers. Inter-tab communication, which to me is, I haven't really gotten my head around whether or not that's bad. One of my colleagues was talking about it not too long ago. It's very interesting to have, within the same origin, tabs being able to communicate with each other via asynchronous message passing. Like that's an interesting influence on an attack surface that we already kind of don't know how to measure very well. WebSockets, web workers, WebRTC, like this stuff is all replacing native functionality and it's just in JavaScript. Like we just get it for free. WebAssembly is the thing that's really kind of exciting me at the moment. Stefan Kraus did some research a week ago where he basically ran some computing problems. The red line is natively performance on C and the yellow line is Java. And he ran these, I guess, these processing exercises in Firefox, Safari, 2 different versions of Chrome against native computations. Now apparently the WebAssembly version in Firefox is quite fast because for some of these it was almost on par with native performance of Java. And that's today. So in 5 years' time, JavaScript will likely be performing at speed as far as like having a binary running on your computer. Anyway, what the fuck am I talking about? What's the problem? I think we're getting to this point where even with things like the same origin policy, JavaScript running inside of your browser has the ability to reach out, and it may not be able to get data back, but it can determine where am I via things like WebRTC, so it can get an internal LAN IP address and obviously where it is out on the internet, and what is near me, as in send a request and wait for the socket to close within a timeout period to determine if a port is open or not. And that's still not very clear, so I'm going to get to the demonstration real soon. But what I've hacked together with some upright duct tape is using WebRTC real-time communications to get internal IP address information, XML HTTP request objects to determine servers within my proximity, a rules engine to tie it all together, and obviously some duct tape, and a lot of beef. So the beef project, hands up people who know about beef. Okay, hands up people who have used beef. Hands up people who have used beef for work. That's fucking cool. You guys rock. I'm gonna bake you all lamingtons. Anyway, so the first phase in our little exercise, the first ingredient is web real-time communications. And for those that haven't heard of this, the idea is that you want to be able to have real-time video chats with your friends, and you don't want to leave a web browser. So WebRTC allows you to do this, and one of the mechanisms it does, one of the mechanisms that it uses to achieve this is the ability to be able to talk directly from peer to peer. And for a computer to talk to its peer, it has to be able to know its internal IP address. So as a part of that, when you establish a peer connection, even if it's not a legit peer connection, it'll start throwing these on ICE candidate events. And ICE, which is the interactive connectivity establishment, will basically say, okay, my browser is listening on these IP addresses and on these ports. And so in this instance, you can see, you know, the local IP address of this computer is 192.168.0.113. So all of a sudden we've started to get a picture of the local subnet, and it's listening on a particular UDP port, which doesn't really matter. Now, tying this with XML HTTP request objects, we can obviously kind of craft arbitrary requests, and even if they go against the same origin policy, they'll close within a certain time period. So ignoring things like port blocking that browsers have, a browser can send requests to an origin and it'll fail, either really fast or not so fast. So you can actually determine if a port on a remote host is listening with some degree of accuracy. The final ingredient is obviously the engine to run this together. In the Beef project, a good friend of mine called Michele, he built this functionality about a year ago called the Auto Run Rule Engine, or ARE. And ARE is basically a combination of a few things. First, you have to be able to target browsers. So you have to be able to programmatically say, when these browsers are hit, do stuff. The second part is the chaining modes. And And so the chaining modes currently have two different modes. So sequential is, okay, if a Chrome browser is hooked into Beef, then run this module, and send me the results. Nested forward is a little bit more complicated, because this is where you can start building some logic. So in this instance, you can't really read it, but the first module is get my internal IP address, and if that succeeds, because the status was 1, take the output of this module and run it through internal network fingerprinting after we kind of mash the output from the first module to kind of build up a subnet range. So this is kind of cool, but the problem is when these run, they run immediately. So the browser gets hooked, these modules run. What I have done is I've implemented a third mode called Dormant Forward, and what happens is you get like a setup phase. So the browser gets hooked. If it meets the target, like the targeting method within the ARE setup, it basically goes, okay, what's my internal IP address? What's my external IP address? What's my ISP's ASN? Like, where am I? So it builds up a picture of where it is in the internet. And then what happens is it kind of then goes to sleep. And it'll monitor network changes. Oh, right, I'm jumping ahead. One of the things that I did do to figure out where the computer was actually was, I implemented a different service on Beef that interfaces with Team Kimru's. Have you guys ever seen, they've got like a bunch of lookup services, and they implement, you can do like reverse lookups and ASN lookups with Team Kimru, and they also release it over DNS, which is super fast. So we've got a web service that you can kind of ping an IP address against Team Kimru, they'll give you the ASN, and from there we can pull out the ISP information. So once we have the internal and external details of the browser, we kick off some timers and some event handling logic. So we basically go, okay, every 5 seconds, am I on a different network? Or has the window.navigator.online status changed? Am I online? Am I offline? And once I've detected that we have changed network, we go, are we back online or are we offline? Are we back on our home network or are we on a new network? And as soon as we're on a new network, we run the internal WebRTC IP lookup, we get the internal network IP information, and then we feed that into arbitrary modules, execute those modules, and then cache the results locally, and then if we ever get back on the home network, we send it out to Beef. So what that means is if you're hooked into Beef and you cross into a different network, you won't talk to Beef, but you'll run modules, store the results locally until you potentially return to the internet, which means that your corporate controls won't pick it up. Now we have some configuration settings, like how stealthy we want it to be, what happens when we return home, and these are just sort of different levels of how chatty we want to be on the network, and also some logic to determine when we get back to our home state, what do we do? Do we just continue to run, or do we kind of dump all our results back to the Beef server and then kind of stop running? The config looks almost exactly the same. So in this instance, the chain mode is set to Dormant Forward, and every single time we get onto a new network, we run a ping sweep against the subnet that we're associated with, or at least a subset of IP addresses. So walking through the scenario, we have a mobile phone, they're on the internet, they get hooked into Beef somehow, they get hooked into Beef somehow, and the payload gets onto that computer, onto the phone, and then it stops. Right, nothing else really happens at that point. Now, if at some point later on the phone ends up on a different network, it'll try to discover internal LAN resources and probe for those and see if it can send requests to those. And at no point will it talk back out over the internet. So it's not going to be making the Beef server, your IR guys aren't going to see that someone's talking to a Beef server, so they're not going to detect that anything's going on. And 9 times out of 10, the Beef payload itself will never be detected by antivirus anyway, so good fucking luck. Anyway, if we return back to the home network, we basically dump our data back to Beef. And so this is me starting Beef. It's super pixely and cruddy, but that should be okay. And you can sort of basically see that as soon as Beef has started, it's already printed out that we've loaded a rule set that's going to run 2 different modules. We're going to run the ping sweep module, and then we're going to run a separate module. So the JSON configuration file here has the port scanner module and the ping sweep module. So that's just the JSON configuration. So obviously you can run any modules you want, but for this example, this is what it looks like. You obviously log into the Beef server, and for those that haven't seen Beef, this is what Beef looks like. It's a boring looking website thing. And to demonstrate and kind of show verbose logging, I'm plugging in my phone into USB debugging, so I don't have to film a phone consistently because you can't read anything off the phone. For those doing kind of mobile JavaScript stuff, the remote devices functionality inside of Chrome is awesome because you can plug it in, you can turn on USB debugging, and you can play around with the console on your computer as opposed to your phone. So you can see here I've plugged in my phone, I've enabled USB debugging, and so now I can control my phone from my computer. And so I'll use my computer to open a new tab on my phone to hook the phone into the Beef server. So I do that just by visiting a demo page just for the demonstration. And you can see the phone is hooked into Beef. It's got the default Beef page. And then immediately the setup phase has begun. And it goes, okay, what's my internal LAN IP address? What's my external IP? What's my ISP? So I've determined that it's with T-Mobile. It's likely on an LTE network. And the browser has showed up in Beef, which is as expected. Now, if the phone drops off the network, so if we go into airplane mode, you'll immediately see that we're in a different state. So we're now offline. We're not talking to any networks. Now, if I join a wireless LAN network, and I'm going to also show that the browser will obviously drop out of Beef, so we're no longer talking between the phone and the Beef server. It takes a little bit for that to refresh. So now if the phone jumps from LTE to a wireless LAN, you'll immediately see like the console spit out a bunch of stuff because it'll determine that it's on a different network and it'll immediately start to run the module. And the first module is the ping sweep. And the ping sweep immediately identifies that there's a server listening, there's a server available on 192.168.0.119. And because it's found an active server, it'll also then kick off the port scanner. So it'll try and determine if there are any ports listening on that server as well. And at no time is it talking to Beef. So this is just on my wireless LAN. So the port scanning capability kind of, you can see here it's failing on FTP requests. So it's using XML HTTP request objects to send FTP protocol requests to arbitrary ports and then tracking how long it takes to fail or not fail. Obviously, we jump back offline by turning off the Wi-Fi and jump back onto LTE. And what you'll see is the phone will basically go, okay, I've checked where I am. I appear to be back home. I'm going to push all my data back to Beef. And you'll kind of see a whole bunch of these data requests start to go to Beef. And then if you jump back in the Beef command and control server, you'll see in the logs that it ran a bunch of modules. And we now have the results from that. And they show up in the network tab, so we get like a little pretty network diagram. The phone has discovered some of the computer, and for that particular host, it's listening on 2 ports, 22 and 8888. So when we ran the port scan module, I think we were testing for 22, 80, 443, 8888, and 9000. So we found 2 of whatever 6 ports that we were scanning. Now let's say we want to queue up a different module so that if the phone gets back onto that network at some point, it's going to run commands against that web server. We can obviously pull up another config file to do like a cause request against 192.168.0.119 against port 8888. And then using the API of Beef, which we have an API, which is interesting, we can obviously list existing rules. We can add new rules to the system. So here I'm doing a post request to send this particular JSON rule file into the system, and then we can trigger it. So we've loaded a new rule, which is ID number 2, and then we trigger rule number 2, and that'll trigger. And then you'll immediately see in the browser, it goes through that setup phase again. So the browser will go, oh, this is what my IP address currently is. This is the ISP that I'm on. So we go into airplane mode, go back onto the wireless LAN, just to see if we can send a request to this arbitrary port on a server on a different network. And if the phone, when the phone rejoins back to the wireless LAN network, you'll see at the top, you can see the network request to this server. So you can see up here, it sent a request. And because the status is 200, for those who have been paying attention, it may indicate that perhaps someone's misconfigured CORS on a web application. And because it's on an internal network, maybe they don't care. So anyway, obviously, we return back to LTE, and then we dump that data back out to the beef server. And then we jump back into the beef server, and then you'll see in the log that obviously it ran some, as soon as I refresh the log, you'll see that it ran some more modules, and you can see the results of the CORS request. And what's interesting here is it's given back an open CORS policy on a website that seems to be some sort of form to send a ping message. And obviously, if you do penetration testing and you see an application that takes in an IP address into like a form field, you're probably thinking, well, is it just going to take an IP address, or are you going to try and put something else in there as well? So let's say at this point we want to try and send a different request to that web server if the phone ever gets back onto that network. So we basically load up a third module that will try and send a GET request against that endpoint, but this time it's going to prepend an IP address with a semicolon arbitrary system command, just to demonstrate whether or not we can get further information or data out of there. We have to do the little dance, load the module, we then trigger the module, and then, we've got to get the phone back on that first network. JavaScript is pretty cool and pretty terrible. Once again, you'll see like the browser will send another request to that port, so you can see the ping command. You'll notice that it takes a little bit to resolve because maybe it takes a little bit to ping. And then once again, we kind of return the phone, and obviously the phone is still offline, so it's not currently communicating with the beef server. It's kind of invisible as far as the internet is concerned. And then obviously if we kind of jump back to the home network, that data will be dumped back up to the beef server. It'll push the results back up to beef, and we'll see if we jump back into that command module, we'll see that it's been run a second time and we've got more results this time. And you can see this, what appears to be a ping response, and at the end of it, a username. Yeah. JavaScript's pretty cool. You talk to IR guys about this sort of stuff and WebRTC and other JavaScript technologies, and it gets pretty hairy with regards to what you can do to defend against this. I think really this really underpins things like zero trust network. I know like 5 to 10 years ago we were able to kind of pretend that an internal LAN was relatively safe from bad actors, either from staff or bad things happening on their computers. I think that day is over. And one of the things I really like about looking at these things from JavaScript perspective is, in general, no AV is doing JavaScript at all. I know the default beef hook payload, it hardly ever gets detected by anything on VirusTotal. Occasionally Symantec will flare up, but then we change like the copyright header to a different year, and then it won't detect it again. And also, it's also kind of cool because I know the Australian Signals Directorate, they kind of push out their top 35 control recommendations. So this is, these guys do assessments for a lot of government organisations, and they're always like, if you do the top 4 of these 35s, you reduce the likelihood of being compromised by like 80 to 90%. And in there, they always put application whitelisting. And your web browser will always be application whitelisted. Like, they're never going to not application whitelist your web browser. So good luck spotting it that way. I I think it really does highlight, kind of the small vulnerabilities that people kind of don't give a shit about anymore, like cross-site scripting and cross-site request forgery, are super important to like not lose sight of how important these vulnerabilities are. I know Ryan from Slack, he's got a Chrome extension that basically kills off his old tabs that have been idle. Maybe we should be looking at for desktop Chrome the ability to basically put background JavaScript to sleep when you're not looking at those tabs. I mean, maybe that's something that we actually need to put into defensive strategies for browsers. Obviously, there's a whole bunch of stuff that I need to do to tidy up. The AS lookup service is super handy, but potentially it's a leak for an IR person to see because we are sending a request back to the beef server, but it's easy enough to spin out onto a different server. I was using some third parties to do ISP lookups based on your IP address, but they kept on blocking me at some point, so it's not super reliable. And I'm sure there's more stuff that I can't remember. Anyway, just wanted to say thank you, everyone. Hope you guys had a great B-Sides. Stay around for the happy hour. I'm happy to field questions, and otherwise I'll be hanging out and having a beer. So thank you. I don't know. Does anyone have any questions? Yes. So the home is based on. I do like partial matching on your internet IP, and then I do like a fuzzy match on your ISP ASN. It's obviously not super accurate, but for some circumstances it'll be okay. Fuzzy matching in JavaScript is also pretty interesting. I mean, not like I've done a lot of testing in that, but it seemed to work quite well between my T-Mobile LTE and my Comcast wireless LAN. Yeah.
But how do you ensure that, or how would you, during a pen test, kind of imagine this is how I'm going to go about getting it onto a device and make sure that it's not read, for instance, out of an email while they're on a corporate network?
Yes. So the question was, okay, so what happens if the browser was hooked when it was actually on a controlled network? Yeah. So I think. I mean, this is certainly it's a fairly staged approach. So you've seen obviously the phone has changed state a couple of times, and you're running kind of some awareness around where it is. If you hook someone and you immediately saw that the requests, like that first hook was coming out from a corporate network, maybe this is not what you need to do. Because if at the point that you're seeing beef communicating out of like a corporate network, you've already got a fairly high foothold. So you probably wouldn't use things like this. And maybe that's a great enhancement, as in, like, I only want to activate when I know that I seem to be in someone's personal network, but as soon as I drop in somewhere different, like actually different as in like a corporate ASN or like an ASN without a name, maybe I should start doing things. The rules engine is pretty cool because it's quite dynamic as far as how you make things hang together, and mostly it's just terribly hacked together JavaScript. So you could definitely put that logic in there if that was interesting. And it's probably not a bad idea. So shoot me a Twitter message and I'll put it on a list somewhere. Yes?
How reliable is the random timeout?
Yeah. So the question... Yeah.
If browsers would randomize that disconnect time,
Yep. So the question was how accurate is tracing the timeouts for XML HTTP requests to determine if a port is open or closed? So we've got a couple of modules that do this functionality right now in Beef. Over time, some of them have proven to be more effective than others, and some of the devs, we still talk about it quite a bit because it's reliable, but then occasionally it's not that reliable. The timeout failing, though, whether or not they would ever implement in the browser versus if you'd implement it out on the server, I mean, whether or not you're catering for this attack, whether or not this would fall into the risk assessment where you'd actually be wanting to try and hide from this sort of thing. I mean, it sounds like it would be a good idea, but I just don't see them doing it. And also because you might have like web services which are on random ports anyway, and obviously Chrome is not going to start tampering with how long that they take to respond. Like I don't see them doing that, or Firefox or anyone. But yeah, it is a hit and miss. For the scanning that I was doing, I was getting on from my LTE network to my wireless LAN, and then I was hitting a virtual machine, and 9 times out of 10 it would detect that particular server and the particular ports on that server, but then occasionally it just wouldn't. And I don't know if that's just my virtual machine just being terrible or not. Yeah, it's not a great science. People do work on it. There's been quite a bit of research as far as like, I guess, doing those asynchronous requests and kind of making assumptions around the timing of the data. Because the problem is the same origin policy doesn't cater for the timing of how long things take to fail. Because they want to give you that when something fails, and they don't want to give you the HTTP status or the result, but they're not masking that timing information. I mean, maybe they will if they see a legitimate threat. I don't know. Did anyone else have any other questions? Awesome. Enjoy the happy hour, folks. Thank you very much.
Thanks, Christian. Always entertaining. On behalf of BSidesSF, San Francisco, and Fitbit, I'd like to give you a Fitbit. And again, there is a happy hour down at DNA. Also, there's food back there. It's going to go to waste, so feel free to grab as many as you would like, or any other treats back there. And then for those who ask questions, we have some of these electronic badges if you're interested. So thank you guys. Be safe.